we want to prove that sine 45 is root 2 over 2. So let's begin with that. To prove that sine 45 degree is the same as root 2 divided by 2, or 0.7071. Let's begin by drawing a diagram that can give us 45 degree. So you know what I'm going to do? Since the sum of the angles inside a triangle is the same as 180 degree, for me to solve sine 45 or to get the angle 45 degree, I am going to draw a triangle, an isosceles triangle for that matter, in such a way that one of the angles in that triangle is going to be 90 degree, while the other two will be 45 each. That will give me 45, which I am looking for. So let's do this. First, I have this isosceles triangle that has 90 degree on top here, and on this side of the triangle, I have 45 degree angle, while on this part of the triangle I have a 45 degree also. I am going to call this triangle ABC. Now, for me to generate the trigonometric ratio, I will be needing the opposite, the adjacent, and the hypotenuse. Don't forget that. So what I'm going to do is to bisect the angle 90 here, so that each part will be 45. Yes, this has been bisected. So what that means is that right here I have angle 45 degree, and on this part of A I have 45 degree as well. So I'm going to call the line at the midpoint M. Yes, I'm going to call it M. This angle AMC is 90 degree, and at the same time angle AMB is 90 degree. Now a good look at the triangle AMC or AMB shows you another kind of an isosceles triangle that has on its base, let's use AC now as the base. So the base of an iso is shown by line AC. So what this implies is that AM is equal to AC, which is also equal to BM. Now to prove this, I am going to take an arbitrary variable to represent the length of AM and AC. So let's say that the arbitrary variable we want to use here is A. Let the length of MC be A. In that case, AM is also A and BM is A. We want to find the value of AC or AB. Both of them are going to be equal, so I can use just one liner to represent both of them. All right, so using the triangle, let's do it this way. Using the triangle ABM, we are going to work with triangle ABM. Okay, triangle ABM. From this triangle ABM, you notice that we have length AM to be equal to A. Also, BM is equal to A, but AB is not known. That is our hypotenuse. In case you don't remember the trigonometric ratios of any triangle, any right angle triangle, we simply use the acronym SOHCAHTOA. SOHCAHTOA. Don't forget this, it has helped us a lot before. Where SO means the sine of the angle. SO is opposite upon hypotenuse, CA adjacent all over hypotenuse, and TOA, it means opposite over adjacent. So the sine of the angle you are dealing with is the opposite of the angle of hypotenuse. The cosine of the angle you are dealing with is the adjacent over hypotenuse, and the tangent of the angle you are dealing with is the opposite over adjacent. All right, so this time our focus is on 45. In that case, For us to be able to apply SOHCAHTOA first, take note that because it is a right angle triangle, we can apply the Pythagoras rule first. So using Pythagoras rule for this angle, or applying Pythagoras rule, okay, for us to find this part, which is currently m squared, we are going to say that m squared is equal to a squared plus b squared to find that length, isn't it? All right, what this implies is that m squared, or m on its own this time, will be equal to the square root of a squared plus b squared. All right, now m squared is unknown. That is what we are looking for, the hypotenuse. So we just write it down here. M will be equal to the square root of, what is the value of our a squared? Our a squared is going to remain a squared, isn't it? So it's going to remain a squared plus, what's the value of our b squared? Our b squared is the same thing as a here, so it's going to show a squared. So what it means is that the value of m is equal to the square root of 2a squared. If we take the square root of a squared, that gives us a. So it means that the value of m, which is our hypotenuse this time, will be equal to a root 2. Take note of this. That is the value of our hypotenuse. So I'll just write it down as a root 2 here. The same thing here, a root 2. Now, since we have reached this level, remember our focus is to prove that sine 45 is equal to root 2 all over 2, or 0.7071. Now let's prove it. Since all the sides are complete with a, and a root 2, let's prove the theorem right now. So I'm just going to use my ruler, create a line here, and proceed to get more space. All right, so now to prove, let's go into sine 45. Sine 45, remember the trigonometric ratios I showed earlier, where sine is the same thing as opposite all over hypotenuse. So sine 45 in triangle ABM, sine 45 is equal to my opposite, which is opposite all over hypotenuse. The opposite angle to 45 here is A, and the hypotenuse, which we just found now, is a root 2. So let's simplify this. That is going to help us find our answer. Simplifying this means we're dividing both the numerator and the denominator by a. So at the numerator we have 1. So it means that sine 45 is equal to 1 all over the square root of 2. When you rationalize this, it's going to be multiplied by the root of 2 multiplied by the root of 2. And when this is done, it means you arrive at 1 times root 2 is root 2, and root 2 times root 2 is root 2 squared, which is the same thing as 2. This becomes your answer. We have just proven that sine 45, degree is the same thing as the square root of 2 divided by 2, which is already in the question given. But is it the same thing as 0.7071? Let's see. Or what is the value of root 2 over 2? Now we are going to use our calculator to do that. So on the calculator, just punch root 2 divide by 2. This gives us 0.7071. 0.7071. But you are not sure yet until you check the value of sine 45 using your calculator. So using my scientific calculator, I'm just going to punch sine 45 equal to the same answer, 0.7071. So my answer is correct. We have just ended up proving that sine 45 is equal to root 2 over 2, or 0.7071. In the same vein, you can look for the values of tan 45 and cosine 45. So let's just do it straight away. What would be the value of cosine 45? Now, using the same triangle ABM or AMB, whichever way you want to treat it, you notice that cosine 45, which is cos, stands for adjacent all over hypotenuse in our SOHCAHTOA. Remember SOHCAHTOA here, okay? So our cos stands for adjacent all over hypotenuse. Using cosine 45, the adjacent is a, and our hypotenuse is a root 2. Just the same thing we had when we did to sine. So if you simplify this by cancelling out the a, you end up with root 2 all over 2. What this tells us is that cosine 45 and sine 45 are the same. Can we really prove that? Let's see if this is true. Cosine 45 and sine 45 are exactly the same thing. Yes, it also gives us the same 0.7071. So we have just drawn a conclusion right now that cos 45 and sine 45 are the same. So I write it down here. Sine 45 degree is the same thing as cos 45 degree, because both of them are the same as root 2 divided by 2, or 0.7071. All right, this has been solved. What about the tangent of 45? Using the same triangle we have been dealing with from the beginning, or the second triangle, look here. Tangent in our trigonometric ratios is TOA, which is opposite upon adjacent, which is the same thing as opposite is A, our adjacent is also A. So it means that tan 45, when you simplify A and A, gives you one whole number. That's it. So we can conclude here that tan 45 degree is the same thing as one whole. Now check your calculator, type tan 45 and see if it's true. Tan 45 gives us number 1. So what's our conclusion? In conclusion, we are going to say that sine 45 and cosine 45 are the same, because both of them give us root 2 upon 2. At the same time, tan 45 can be proved to be 1. Tan 45 is equal to 1. And this means that tan 45 is actually the same thing as sine 45 all over cosine 45. Or you can say that tan 45 is the same thing as cosine 45 divided by sine 45. Since both of them are equal to each other, the answer will also end up being 1. Let's prove that at the same time. See, if you use your scientific calculator, punch sine 45 divided by cosine 45, your answer is 1, which is the same thing as tan 45. Now reverse the punching and punch first cosine 45 divided by sine 45. That also gives you 1. So whichever way you reverse it, as long as it's 45 degree you are dealing with, you are going to end up having cosine 45 divided by sine 45 is the same thing as tan 45, or sine 45 divided by cosine 45 is also the same thing as 1. Whichever way, we have ended up proving that sine 45 is exactly 0.7071 or root 2 upon 2. That's the first question answered.